So we're going to take a look at solving absolute value inequalities. And there are two basic examples and then some special cases that we'll also look at, but two basic examples. So we have here the absolute value of x is greater than or equal to 5. Okay, let's substitute for x. So we have the absolute value of x is greater than or equal to 5. I'm going to utilize 0 for x. So we have the absolute value of 0. Is that greater than or equal to 5? Well, that means is 0 greater than or equal to 5? It is not. So therefore, that's not a solution. Let's try something else. How about 3? So we have 3 on our number line. Is 3, the absolute value of 3, greater than or equal to 5? Meaning, is 3 greater than or equal to 5? It is not. In fact, let's keep going. How about 5? The absolute value of 5, is that greater than or equal to 5? It is. It's equal to. And so I can shade 5. Okay. How about 6? Is 6 greater than or equal to 5? It is. So I know 6 is going to be in our final solution. How about 7? Is the absolute value of 7 greater than or equal to 5? It is. And in fact, I'm going to redo this. We would have a circle at 5 and we would shade everything to the right of 5. That's part of our solution. But that's not all. If I were to use -5, so the absolute value of -5 is actually 5. So when you take the absolute value of -5, you get 5. And 5 is greater than or equal to 5. So -5 and everything to the left is also a solution. So I did that just by guessing and checking, but let's have a more methodical way to do this. So just like when we had equations and we separated into two equations, inequalities, you also want to make sure you isolate the absolute value expression and then separate into two inequalities. And so here, whenever you have greater than or equal to, I want you to make note of that's going to amount to a compound inequality for or. So in this case, we're separating into x is greater than or equal to 5 or x. We're going to flip the symbol when we do the one that has the negative. X is less than or equal to -5. Just notice how I flipped the symbol. So when we look at our graph, the x is greater than or equal to 5. That's the right side of our graph. Or x is less than or equal to -5. That's the left side of our graph. So when you have greater than or equal to, remember you're separating into two statements that amount to the compound inequality or. Analogous to that, our second example, we have the absolute value of x is less than or equal to 8. Whenever you have less than or equal to, okay? So less than or equal to or less than, the compound inequality is going to be with an and. So in this case, I'm going to skip the guessing and checking and just go straight to writing these separate inequalities. We have x is less than or equal to 8 and x is greater than or equal to -8. Those are our two inequalities. So when I put this on my graph, essentially what I'm going to get, a solid circle at -8, a solid circle at 8, and I'm shading in the middle. Okay, so there is my graph for the second case. So in general, what this means for us is absolute value inequalities are really just compound inequalities. Excuse me. Okay. All right, so let's try some examples. In the first example, we have the absolute value of x is greater than or equal to 4. So remember, greater than or equal to is going to be an or compound inequality. So we have the absolute value of x greater than or equal to 4 means x is greater than or equal to 4, or x is less than or equal to -4. That is the equivalent. Now I can graph these. So x is greater than or equal to 4, solid circle at 4, and then I'm going to the right. And then the second part of this, solid circle at -4, and I'm shading to the left. There's my complete graph. And my interval notation, I'm going to write parenthesis, -infinity, comma 4. I'm sorry, -4, square bracket, union, square bracket, 4, comma, infinity, parentheses. So because we have two parts to the graph, you have to have two parts to your interval. All right, number 2. We have the absolute value of y is less than 7. So remember, less than or equal to, your compound inequality is going to be and. And so I'm going to separate this into two inequalities. Our compound inequality, we have y is less than 7 and y is greater than -7. So when we graph this, we're going to have an open circle at 7, an open circle at -7, and we're shading between those two circles. So for our interval notation, we have parenthesis, -7, comma, 7, close parenthesis. Open circle is not a shaded circle, so you have to use the parenthesis. Okay. So number 3, we have the absolute value of x is greater than -1. Now be careful, because you might think because it's a negative on the other side of the inequality statement, automatically it means no solution. That's for an equation, but when you're dealing with an inequality, you're not saying equal to, you're giving a range of numbers, and it's possible that there could be solutions within that range. So let's think about what this means, okay? So I'm just going to pick a number, right? 0. Is 0 greater than -1? It is. So I already have just showed you that there's a solution here. What about 1? Is the absolute value of 1 greater than -1? It is. So let's just go with the mechanics of what I gave you. I said greater than or equal to gives you compound inequality for or, our union. So that means I would write the x is greater than -1 or x is less than 1. Okay, if I do scratch work for that, x is greater than -1. That will be an open circle at -1, and I'm shading to the right. If I do x is less than 1, that will be an open circle at 1, and I'm shading to the left. Now remember, when you have an or compound inequality, that's a union. That means you're combining both graphs to get a total graph. And in this case, when you put these two graphs together, they make up the entire number line. They make up every real number. So we would graph the whole number line, everything. So regardless of what number you pick on the number line, it's going to be a solution here. So our interval is going to be from parenthesis negative infinity, comma, infinity, close parenthesis. All right, so that one you have to think through. Do your scratch work, put your graphs together if it's or. Okay, now let's take a look at number 4. Number 4 is kind of tricky as well. So this one, you have the absolute value of x is less than 0. So the answer might not jump out at you, all right? But what we do know is that if we were to write the compound inequality that may go with this, it would be x is less than 0 and x is greater than 0. So if I do the scratch work, x is less than 0, it's an open circle at 0, and we're going to the left. X is greater than 0, it's an open circle at 0, and it's going to the right. Now remember, when you have an and, you're doing the intersection. Where do these graphs intersect? Where do they have points that are the same, that are in common? Well, they don't. There are no points that are in common. And so this is an example where this is no solution because there are no common points. No solution, which we can also represent by writing the 0 with the slash through it to show the empty set. All right, let's look at some other examples. So here we're just getting more involved. We can see here we have the absolute value bar x minus 1, absolute value bar greater than 6. So our absolute value expression is isolated, so we don't have to do any more work. But we do need to separate into two inequality statements. So we have greater than or equal to. We have greater than. So this is going to be an or compound inequality. We have x minus 1 greater than 6 or x minus 1 is less than -6. Okay, let's solve these. Add 1 to each side for both inequalities. So that gives us x is greater than 7 or x is less than -5. So putting this on our graph, x is greater than 7 means an open circle at 7, and we're shading to the right. X is less than -5 means an open circle at -5, and we're shading to the left. Okay. Nope, we don't need both of those graphs. And then our integral notation, we're going from, we have two parts, so we have to go from negative infinity, comma, to -5, parentheses, our union, parentheses, and then we have 7, comma, infinity, close parentheses. Okay, Let's take a look at the second example. We have here an absolute value bar, x plus 2, absolute value bar less than or equal to 7. Go ahead and try this on your own and pause the video, and then we'll do it together. Okay, hopefully you had some success with that. So to begin with, we see we have a less than or equal to sign, so we know that's going to correspond to our compound inequality for and. I'm going to write the two inequality statements. We have x plus 2 is less than or equal to 7, and x plus 2 is greater than or equal to negative 7. So let's subtract 2 on each side for both statements, and that gives us x is less than or equal to 5 and x is greater than or equal to negative 9. Okay, let's see what we get. Let's do our scratch work. X is less than or equal to 5, meaning a solid circle at 5, and we're going to the left. Greater than or equal to negative 9 means a solid circle at negative 9, and we're going to the right. Remember, this is an intersection. So it's going to be between negative 9 and 5. So put on my graph negative 9 and a solid circle at 5, and I'm shading between the two. All right, so in interval notation, we get a bracket and negative 9, comma, 5, and then a square bracket. And that is that. All right, we have two more examples here. All right, and so you have the absolute value of 3x is greater than 12. And then you also have the absolute value 2x plus 5, absolute value bar greater than or equal to 3. Go ahead and pause the video, do these two, and then we'll do them together. All right, so let's start with the first one. We have greater than, so we're working with or. So that means we have 3x is greater than 12, or 3x is less than negative 12. Let's divide by 3 on both sides for both inequalities. So that gives us x is greater than 4, or x is less than negative 4. All right, let me move the graph up. There we go. All right, so this would give us an open circle at 4, and we're shading to the right, or an open circle at negative 4, and we're shading to the left. All right, so our interval, we need two pieces to it. So we have parentheses, negative infinity, comma, negative 4, parentheses, a u, then parentheses, 4, comma, infinity, close parentheses. All right, second example, we have greater than or equal to, so we still have or. So we have 2x plus 5 greater than or equal to 3, or 2x plus 5 less than or equal to negative 3. All right, so I'm going to draw a line to separate my sides for my inequalities, and we're going to subtract 5 on each side for both inequalities. All right, so for the first inequality, that's going to give us 2x is greater than or equal to negative 2. The second one, we have 2x is less than or equal to negative 8. We're going to divide both sides by 2. So that's going to give us x is greater than or equal to -1. And the second one, we have or. The second one, 2x is less than or equal to x is less than or equal to -4. Okay, let's graph that. So x is greater than or equal to -1. That means a shaded in circle, and we're shading to the right. Second part, less than or equal to -4, a shaded in circle, and we're shading to the left. And so our interval has two parts. We have parentheses, negative infinity, comma, -4, square bracket, because the circle is shaded in, saying equal to. Then union, square bracket, -1, comma, infinity, parentheses. All right. You'll want to make sure you jump right into your homework for these. And if you need to refer back to the videos, feel free to do so.